Okay, 7A, we did these notes in class, but I'll put them on, I'll put these on obviously online. So 7A is we're just given an equation to determine the number of real and complex solutions. So first thing, we're at example 1, look at the biggest exponent. Biggest exponent will determine how many solutions there are. So it equals the number of solutions. So in this particular problem here, biggest exponent is 4, so we have 4 total solutions. Now we need to determine, are these solutions real or complex? So we're going to put it in the calculator. So now it's in the calculator, we're going to graph it. And it crosses the x-axis twice, 2 different spots. When it crosses the x-axis, these are known as real solutions. So I have 2 real solutions here. I have 2 real solutions. And since we had 4 total solutions, 2 of them are real, the other 2 automatically have to be complex. There are 4 total solutions. So I can see that I have 2 real from the graph. The other 2 have to be complex. So let's do the second problem. So again, biggest exponent tells us how many solutions, so there are 5 solutions here. Now we need to put this into the calculator. So I have it in the calculator now, go to graph it. See how many times it crosses the x-axis? Once, twice, 3 times. So it crosses the x-axis 3 times. So that means there are 3 real solutions. And because there are 5 total solutions, 3 of them are real, the other 2 have to be complex. And this is what 7A is all about. We're on 7B. 7B, we're talking about identifying zeros of multiplicity greater than 1. Zeros are x-intercepts. These are x-intercepts. And multiplicity greater than 1. Some x-intercepts, there are more than 1 solution at that x-intercept. So that's what we're talking about, multiplicity greater than 1. We call these double zeros. Come twice. Multiplicity 2, 3, 4. Most of the time we just deal with it in this class as multiplicity 2. Some quick examples of graphs. If you ever see a graph come down, come back up, or it comes down, that's known as a double zero. We count a double. You have the graph. So there's multiple zeros here. So this is the only one that we count double, twice. This one here that's a single. There's only 1 solution there. And this is another single solution. But when the graph comes up, hits the x-axis and goes back down, or comes down, hits the x-axis and goes back up, those are known as double solutions. So now we are looking at, again, back in the calculator. For example 1, all I'm doing is identifying the zeros with multiplicity greater than 1. So I don't want, going back to the last problem, I don't want the singles at all. I just want the double solutions. So let's look at calculator. So let's back at the calculator, let's graph this. Can't quite tell what's going on here, so I'm going to zoom in. So I'm using the zoom in feature to be able to see the part of the graph I need a little bit better. Again, I can't see very well, so I'm going to zoom in again. And I can see across the x-axis twice. And there looks to be only 1 double zero. It's the first one from left to right, it's the first one. So I'm going to go to second trace 0. I need to go left of the x-intercept I want to find, my double. And, right, well, there's the x-intercept, so I'm going to go left a bit, enter, right bound, go to the right of the x-intercept, enter, yes, just hit enter again, and this x-intercept is at -1. So that is my double, that is the double. We would count it twice if we were writing out all of the x-intercepts. Last example. Let's put this into the calculator. So I have it in the calculator now. Graph it. Uh-oh. Not graphing correctly. Whatever happens to you, Zoom 6. You're probably telling me that already. Zoom 6. Look at the graph. I can't tell what's going on here. So I guess let's zoom in again. And it looks like it hits the x-axis, bumps back up, and hits again, bumps back up. If you want an easy, quick way to check, sometimes go to the table will work, and you're just looking for where the y is 0. So 2 and -2, those are my zeros. And look back at the graph, -2 and 2, those are points where it comes down, hits the x-axis, goes back up. So x equals -2 and 2, those are your doubles, double zeros. Yes, well, if you have any questions, come to class with those. Otherwise, 7C is your homework for tonight.